over, there's two parts in this section, combinations and the binomial expansion theorem. Yeah. I don't think we'll get to the binomial expansion theorem today, which is fine. We can do that tomorrow. It's Friday. No big deal. It's a pretty easy scenario. If you guys know anybody in pre-calc right now, the unit they just finished out was working with binomial expansion. And the pre-calc book does it a really weird way. But then like Lena was talking to me 2 days ago. She said, hey, by the way, what you showed us last year for binomial expansion is a HE double hockey stick, a lot easier than what they're showing us now, because it's just... I don't know. I'm being nice today. Lena? No, Lena, she's somewhere. Once again, the differences between what we talked about yesterday were permutations, and today we're talking about with combinations. Permutations, your order in which you select things, matter. For example, we're talking about, if you're looking at baseball, or the order in which you can bat first, second, third. That is a pseudo permutation. When we're looking at how did you select, what was the play? When you had the play where you had the two students, the principal, the janitor, the baker, the Quaker, the candlestick maker. They all had their own role in their play to try to figure out where they go. Because if you're one person, you're not another, unless you're schizophrenic, and then you're schizophrenic. Michael.
What was this?
12-2. Combinations and we're combining the combination and binomial expansion there. Sorry.
You tried.
I do. So combinations, order doesn't matter. And once again, there's going to be this wacky formula for how these look. It's n choose r instead of n permute r. What I want to permute, excuse me. What I want to look at here is every once in a while we'll probably crank one of these out by hand. Because remember yesterday we did the permutations, you're able to drop your fractions rather easily. This works the same way here. You're going to see a lot of these fractions can simplify, and you wind up with a lot of pretty easy mental math. Now, there is a button on your calculator. It's right next to where your NPR was. I believe it's the one right below it, if I'm not mistaken. So there's values to do this. And a real nice example, and I totally forgot to grab them from the office, was possible ways of dealing a deck of cards. Okay? Now, if you deal, go get a deck of cards. Real quick here. One of the easy ways of looking at how combinations work is when you're dealing a deck of cards. Now, if you're dealing a deck of cards and you want to do a poker, it's 5-card poker, that means, does the order matter when you deal a deck of cards? No, because usually what happens is you wind up reshuffling them in your hand. It doesn't matter what they look like when they come out to you. So as you pull through that, you have 52 cards to pick from. We all know that, right?
No.
Yes. No.
Now we do.
Let's label out, because cards come into play a lot over the course of the next month or so. So when you have a deck of cards, there are 52 cards. Okay? You have 52 cards. You ever hear the game? You hear someone ever ask you, "Hey, you want to play 52 card pickup?"
Yeah.
You have 4 suits. You have, let's see if I can do this. You have diamonds. They're a girl's best friend.
Why does it look like that?
Nobody asked you. You have hearts. You have a spade.
Selling You just ruined my favorite.
Why use the middle name?
That kind of bottom.
You can do diamonds.
Nice.
Wow.
You have a spade and a clover. A club.
The art skills.
Now, yes, this is why people have never asked me to draw for them.
That's why we should always ask you to draw for us.
Yes, because you get a little intermediate humor.
Makes me feel better about myself.
And that's point for me. One of the things you'll hear about is black or red. Half the deck is black, half the deck is red. That means 26 of each. I know, math is strong with this one. There are 13 cards in each suit. You have the numbers 2 through 10.
Wait, what about one?
Jack.
Wait, I'm confused. Ace.
Ace.
Oh, you know,
No, there's a one and an ace, right?
No.
Ace is
No, or the ace can.
Hey, Phoebe, you want to play blackjack? I'll play it.
I will.
The face cards are technically Jack, King, or Jack, Queen, King, Ace is an ace. It's the place with the help for hardwood.
I thought you do that too.
I want to roll! Give me some dice! Oh wait, number
Sin.
Give me some.
It's not a 9 Inch Nails song.
You should be able to say dice. You've already mentioned blackjack.
9 Inch Nails, band.
And poker.
Sin is a song.
Gambling rocks.
So the probability, or not, I don't want to talk about probability yet. We're not there. But yeah, I can't shuffle. Save my
Teach us
life.
the count cards.
Get there. What happens here, if you want to, the possible number of, is there 2 S's in possible?
Yes.
Do you know what class this is?
Math.
Okay.
You can't make an excuse. There's a lot of letters in math.
Oh. Okay.
There's a door. Possible poker hand. Shut up. Combinations. If you're going to deal out 5 cards, we're just dealing 5 cards here. If I'm going to deal out 5 cards, please. One more. If I'm going to deal out 5 cards, the order doesn't matter in which they're coming out. They're just going out there. So here's a hand. That was pretty smooth, wasn't it? Here's your 5 cards. I'm not playing against you. All right. Are you? So how many cards are in the deck?
52.
We have 52 cards in the deck. We're choosing 5 of them. Okay. You have 52 cards in the deck. You're choosing 5.
Are we still using jokers?
What's that?
Why would you use?
Why would you deal with a joker?
Okay.
It's poker. You don't use poker.
I know, like, I was
Hey,
asking,
never mind.
I was asking if you were looking at stuff.
Now,
It's okay.
what form?
Hey, I'm with you.
Jokers, like any game.
Why didn't you draw a
What game have you
Now,
played?
in this case, if you want to look at it, long form. Long form, it would be 52 factorial over the quantity 52 minus 5 factorial, 5 factorial. This is actually very, very easy to compute by hand. Remember, 52 factorial is 52, 51, 50, and so on, all the way down the line. 52 minus 5 is how much?
47.
It's 47. So, in essence, I only really need to write out 52, 51, 50, 49, 48. Why?
Because the other one cancel out.
Because the 47s are all going to cancel out. Does that make sense?
Yeah.
And then now it's all going to be over. 5, 4, 3, 2, 1. Okay. Now there's a couple of things you can do. In this case here, you could do what 5 times 2 is how much? 10. So if I take the 5 and the 2, I can simplify the 50 to become what?
5, 5.
5. Oh, then the 48.
Okay, everybody see that?
Yeah.
All I'm doing is just a quick little simplifying.
And
And
then
then
12,
the 12 goes into 48 how many times?
4.
So the numerator really is 52, 51, 49, and 20. What I'm looking at here is, could you simplify the fraction out completely without multiplying it out by hand?
Then do, is that our
Can you explain why 50 became 5 and 48 became 4?
When I took 5 times 2, what do you get?
10.
Well, 50 divided by 10 is what? All I'm doing is simplifying the fraction.
Okay, so you're just taking out things that.
I'm taking out factors of 1. I'm taking out GCFs, if you will. I'm simplifying out over the numerator versus the denominator. Okay?
right above
Now-
that would be, and then you take notes.
No, it should be, because it's 5 times 4, because 12 goes into 48 4 times. Okay? Jared?
So if we're doing it by, if we were to like have to do it by hand, would that be our final answer?
Yes.
Okay.
Great question. Jared just asked, if you were to do this by hand, would this be your final answer? Yes.
So you don't have to multiply it out?
No. So if I asked you to calculate that out by hand, that would be something I would expect you to be able to do.
Why do you stop at 48? Why do you do it?
What happens with the formula for the choose for accommodations is that you take the 52 minus the 5, that goes down here. 52 factorial goes 48, then it's 47 all the way down. That's already duplicated here, so we can simplify it out.
It's 2,598,960.
That is?
Yeah.
That's a big stinking number.
Got it in my head.
No, you didn't. Nice try. He's like,
Why did you have the 5 factorial here?
it's the rule. Remember the rule from the theorem there, the definition of it? Oops. Who's this?
Oh, okay.
That's all it was. I was just rewriting it via the exact example. Okay? So if you're looking at being able to do deck of cards, we have, what was our total possible then? What was it again?
2,000,000.
Wait, 2 million, too many people yelling.
598.
598,
960. 960. Jared, what'd you do, man?
If you got a .74, you did something wrong. You get shot in the Old West if you have .74 of a card. That means you're cheating.
Yeah.
I mean, you're cheating. That's like folks move alongside and hide you. Now, another way of looking at this is how many of these hands that you can get where you can get all 5 cards the same suit. So basically you're asking, can you get a flush dealt to you right away? A flush means all of the same suit.
Royal plus.
Royal flush would be ace through 10, same suit. That'd be pretty good.
Yeah.
You cheated.
12 and like that's 3 milliliters. And I did not cheat.
Oh, that's not good. Anyway. So, when you work through something like this, there are multiple things that have to occur. What is the first thing that they're talking about?
5 cards.
You get 5 cards of the same suit.
13 cards in one suit.
So you have to pick a suit, don't you?
Yeah.
Okay. How do you pick a suit?
Yes, so 13.
But how would you write that out? How would you say that if you're picking out a suit when you're looking at it?
Divided by 13.
By what? By 13.
The answer.
52.
Because it would be, the odds would be high.
48.
Well, you're starting to overthink it.
Multiply by 4.
2,590,600.
You're overthinking it here. How many suits are there?
4.
How many you have to choose from?
4.
So, how many are, let me rephrase
Four,
that.
choose one.
That's all it is. You're choosing a suit first. So, once you pick the suit you're looking for, I mean, it's not like you're really doing that. You're hoping that when you shuffle these out, sorry, I didn't do a good job. I have a heart, because I'm a loving person, and I care. Said the math teacher when, getting ready to sign homework. Now, after that, it's asking you, you've got your suit. How many cards are in a suit?
13.
And you want to choose how many of that?
5.
You get these little compounding style combinations. You're putting two things together. This is a weird concept for most students to start to think about. It takes a little bit of time. Once you do a couple of the way that things are worded, it's pretty easy. So let's see if I'm working. Michael.
So the 4 is the amount of suits, and the 1 is that same suit.
Yep. Ooh, I have a 4, 5, and a 6. I lose. I'm not going to win any money.
Use game over life.
You get
I did.
a 4, 5.
Use all, man. It's fun.
College.
College. They're in kids' college.
All right. So when you multiply those two together, what do you get?
5,140.
So that's how many of the hands, of the total possible hands, are all the same suit.
So we multiply like that.
So what? Izzy, one more time. What was the answer?
I got 5,148.
28.
48.
48, yeah.
Just type that in your calculator, like exactly how you said it.
Yep. Now think about it. The probability of getting that. Do you guys remember just real briefly how do you get probability? How do you solve probability?
The first one, this one divided by like the
Correct. So if you think about the probability of getting a flush, which is what this is called, all the same suit, would be desirable outcome divided by, what was our total earlier? 2,968,000.
998.
Wait,
Or
wait.
598.
598.
Jesus,
598.
Oh my goodness.
That's a 6 on
598,960.
There's from the 49, or the 50 times, it's 2,598.
Now, we're not really dealing with probabilities yet, but just to show you, if you take, thank you.
We got a solid 0.198079231.7%.
Do you understand why the probability of getting a flush being at 0.19%, why that is a winning hand? Because it doesn't happen very often. That's why they start looking at probabilities when you're looking at possible outcomes. That's how the counting of cards starts to play in.
What's the chances of a royal flush?
Well, how many ways can you get a royal flush?
Well,
4. There's only 4 possible ways to get a royal flush out of all the
So if
decks.
you do like 4 divided by that or whatever, or would you have to do more like the combination?
It gets into it. It's a lot more precise. When we get into the probability, I'll show you. It's a little bit more in depth than that because there's only 4 out of all the different combinations. So it would be 4 divided by that. So you have a big old. What's that?
Yeah, 1 point.
I honestly don't like to play cards because I am a math person and I see numbers and I start thinking this, and I don't like that. No, it's not the cheating. I don't like overthinking. I like to just,
Subtract.
yeah, it's just, I like to play baseball, I like to play golf, I like things that I don't need to, not that you have to think, but,
You don't need to.
my mind will see, okay, if I'm playing blackjack, and I'm sitting here, I'm at 19 and 8, I'm like, okay, probabilities, this, that, and the other, I don't want to do it, I want to stay, and it just makes my mind hurt, and I don't like that. So. Now, we have these things when you're dealing with these combinations, there are times that you're going to multiply them together, like we just did, and there's going to be times that we're going to add them together. When you're adding them together, it's kind of a really easy way to look at it. I'm going to kind of go right to an example because I'm going to run a little bit short here. When you want to find the number of ways both an event, one event, and another event can occur, you need to multiply. What we're talking about there was 5 cards of the same suit. 2 different things have to occur. When finding the number of ways an event or something else can occur, when 2 things with the word or, that's when you're going to add. Okay? When you get used to seeing this a little bit, it's so very simple. And 2 things you want to happen, multiply or adding. Let me show you an example here. Restaurant serves omelets that can be ordered with any of the ingredients shown. Suppose you want to have exactly 2 vegetarian ingredients and 1 beef ingredient in your omelet. How many different types of omelets can you order? So what do you see in there? You see the word and then you see the exactly. Okay. Now in this case, you want it exactly 2. So you're gonna choose 2 of the vegetarian. How many veggie options are there? 6. So it's 6, choose 2. And you want to multiply that by choosing how many of the meat ones?
1 out of 4.
So it'd be 4, choose 1. I know you want to say it like that. It's 1 out of 4. You want to choose 2 out of 6. But remember, there's 6 of them you're choosing 2. The lingo as you get into it is how it's going to work. Now, the other one, it says you can afford at most 3 ingredients in your omelet. How many different omelets can you order? Well, if you're going to be at most, that means you can pick no ingredients, just an egg, or 1 ingredient, or 2 ingredients, or 3 ingredients. Does that make sense? So what you're looking at there is you've got these combinations for part B of, well, there are 3 ingredients is what you pick out of. It doesn't, out of what?
10 ingredients.
Correct. And I was just about to say, it doesn't designate meat or vegetable. It just says ingredients. How many ingredients are there? There's 10 of them. So you could take 10 ingredients and not choose anything, or 10 ingredients, choose 1, or 10 ingredients, choose 2, or 10 ingredients, choose 3. Do you see how the vocabulary of that is very subtle, but it's not crazy? It's a very subtle difference in how it's worded. Okay? Very, very subtle. The at most, at least, that's pretty much a dead giveaway. It's going to be an and problem because you're looking at adding things in or subtracting things out. Okay? Want to give some of these a try? And we'll continue this tomorrow.
Sure.
There's a lot to these things, and I'm in really no hurry to go through a lot of it. So let's do this. So what I gave you there was 5 card problems and a couple of some combination with whether or not you might have to multiply or add.
What's that word?
No 51.
No 51.
I thought you like nosy with an eye.
That's what I thought too. I was like, oh.
Can't spell. So it might have been.
I capitalize the N next time. Just saying.